All right, welcome to Algebra 2. Go ahead and turn your books to page 540, lesson 76, factoring polynomial roots. What roots mean is wherever that graph hits that y-axis, that's considered your roots here. For example 1, to find your roots, you always factor, and whenever you factor, you set each of the binomial, the trinomial, set them equal to 0. And for this one, 2x equal to 0. Solve for x, you end up with 0. X is equal to 0 here. X minus 5 equals 0. That means you're going to add 5 to both sides. Your answer will be 5 for the second one. Third one, 2x minus 3, you're going to set that as well equal to 0. You're going to add 3 to both sides. 2x equals 3, divide by 2. You're going to have 3 over 2, and that would be your third one. So those are your three roots. That means when you graph that type of graph, when you despan it, you'll end up with a graph that hits at 3 points, which is at 0, 5, and 3 over 2 at the x-axis. For these type of problems, they get a little bit more complicated because they're not just the trinomials anymore. They have the highest power of cube, they have the fourth power, they have the fifth root, or the fifth power. So here, I have steps down here. If you want to take a picture of it, zoom in so you can have it there for you. This will be very, very helpful when you do these type of problems. First thing you do, you factor the greatest common factor, whether it's a number or variable. Second thing, if you factor out and you end up with a trinomial, if it's a quadratic formula, so a quadratic equation, meaning x squared, so the highest power is that squared, you're going to first factor it, like the trial and error way that we learned, or use quadratic formula. So if you can't factor it this way, you always use quadratic formula to back you up. If you factor and you end up with q being the highest power, then there's two ways that you can do these type of problems. First thing is you need to graph it. When you graph it, there's an app called Algebra. I'll have it down there for you, and that's the app that you'll need to solve for these type of problems, because you need to see where that x or that graph hits the x-axis. So you graph it, and then wherever you find where that graph hits the x-axis, you're going to divide that number by your expression there, and we'll do an example. Or let's say that graph hits the x-axis at some random decimal, like 1.795 or something like that. Then, if it's irrational, so the numbers don't make sense, it's out of order, that means your decimal will be, that'll be your answer. X will be that, and then you won't go any further from there. So example 2. First thing we're going to do, we're going to factor. So we're going to factor out any greatest common factor, and that is 2x. Then we're left with 3x squared plus 5x plus 4. Oh, plus 2. Now we factor it. So we can do factoring the normal way or using quadratic formula, so if you like that way. So you can use both. The book has a quadratic formula. I'm going to do the factoring way. So not focusing on the 2x, I'm going to leave it later. When you have a greater than 1, you multiply the 2, I get 6. Find factors of 6 that equal 5, and that is 3 and 2. And then, remember, you bring the first term down, the second term down, or the last term. And then plus 2, and then these two will be your middle terms. You group the first two, the last two. The greatest common factor for this one is 3x, and you get x plus 1. The common factor here is 2, and you're left with x plus 1. And then you see what they have in common. They have the x plus 1 in common, and you're left with 3x plus 2. After that, we have, and we can bring this down here, 2x times x plus 1 times 3x plus 2, and we go ahead and we find the common factor. So we set them all equal to 0. So 2x equals 0, you're going to end up with 0. X plus 1 equals 0, move the 1 over, you get negative 1. And 3x plus 2, I'm going to do this because it requires a little bit more work. 0, you get 3x equals negative 2 divided by 3. And then your last root is negative 2 over 3. So those three numbers will be your answers for the root. B, so we have x to the fourth minus 3x cubed and that whole expression there. First thing we do, we always factor out greatest common factor. So the greatest common factor here is just the x. They at least have one x. There's no numbers I can factor out. So I'll have x cubed minus 3x squared plus 2x minus 6. Now we have a cube. When you go over here, if it's a cube, you graph it, and then the book has it graphed, so I'm not going to graph it there. Here, you have the graph right there. Oops. You have the graph right there, and they intersect at x equals 3. So what that means is you're going to divide x minus 3, because it's always x minus whatever that number is, so that number is positive, so it'll be x minus 3. You're going to be dividing that to this term right here. So we're going to do 3 divided by, I'm going to use synthetic division, it's faster here. So x cubed is just 1, has a coefficient 1, negative 3, 2, and negative 6. I'm going to go ahead and use synthetic division or regular division like they have in the book, and you solve for it. So you bring this one down. 1 times 3 is 3. This equals 0 because you're adding. 0 times 3 is 0. 2 plus 0 is 2. 2 times 3 is 6. Negative 6 plus 6 is 0. Remember, whenever it's a 0 in the end, that means it's a factor. When I go ahead and put this in terms of factoring, so before I do that, I have to bring that number down. I factor that. I have to make sure to bring it down because that's what I'm including. Remember that the x... Alright, sorry about that. I cut off. So here you have your first one, the number you originally, or the variable you originally factored out. Then you have what you divided by, and that's the 3. Remember, it's in terms of x minus 3 because x minus 3 equals 0. You add 3 to both sides and you have x is equal to 3. That's why it's like opposite signs. So you have your x minus 3, and then you have this last term that you just factored out. Remember, this is considered the remainder. The last one is remainder, and I always work from right to left. So it's remainder, then it's your constant, then it's your x, then it's your x squared. So here I have 1x squared, I don't have an x, and I have plus 2. And now, since I have all 3 of them, I set them equal to 0. So x is equal to 0. 0. X minus 3 equals 0. I'll end up with 3. So that graph intercepts at 0, 3, and let's look over here. X squared plus 2, I'm going to go ahead and set that equal to 0. I subtract both sides by negative 2, so I have x squared equals negative 2. I square root both sides, and I end up with x being the square root of negative 2. Remember, when you have a negative underneath the radical, you take that negative out, and you have an I radical 2. This is considered a complex number, and this is not a root. Roots are real numbers. So in this case, real numbers could be rational or irrational. If you can see it there. There you go. Rational or irrational. But solving it out, I get I radical 2. That's a complex number. It's not a real number, which goes hand in hand with real roots. So the only 2 answers that you have is 0 and 3. Now example 3. All right, example 3. Now we have 2 types of binomials and they're subtracting. So we have one term here, we have another term here. We find like terms of each one. So the like terms of each one, they each have an x plus 3. So I will go ahead and cross that out. And remember, just like what we did with dividing for example 2, we go ahead and just grab the remains. So we have x squared plus 4 on one side. It's minus. Whenever you have subtraction, I always put the minus sign and the parentheses of what I'm subtracting by. Subtracting the 4x plus 1. Now I go ahead and simplify it. So I have my x plus 3. Then I have my x squared plus 4. I'm going to go ahead and get rid of that parentheses by distributing the negative sign. That means it changes the sign. This becomes a negative 4x. This becomes a negative 1. Then I add like terms. So x squared minus 4x plus 3. And then from this point, I go ahead and I divide. I try to see if there's any terms. It's a squared, so that means I can do factoring by trial and error. If it works. If it doesn't work, there's a quadratic formula. So here, x squared minus 4x plus 3 factors of positive 3 that equal negative 4. And your answer is x minus 3 and x minus 1, right? Negative 3 times negative 1 gives you positive 4, or sorry, positive 3, but when you add them, they give you negative 4. So now I have these 3 trinomials. I go ahead and set them equal to 0 and solve. So I have here negative 3, I have positive 3, and I have positive 1, and those 3 numbers are my answers. Last one we have here, same thing. So first term, second term, I go ahead and factor out what they have in common. If they don't have anything in common, I'm for these problems, you will have something that they have in common. Unless you want to multiply them all out, but you won't have to. So now, factor out common factor. That's a binomial. I'm left with 3x cubed plus 4. Here it's plus, so I'm not really going to add the parentheses because it's simplified. I don't need to do any extra steps. So 5x squared minus 1. From this step, I go ahead and simplify. So 3x squared, oh, it's cubed, 3x cubed plus 5x squared plus 3. It's a cube. So for cubes, we go ahead and graph it. So we go back to what I had for the steps over there. You graph it and then you divide by the x-intercept. In this case, when you graph it, where that graph hits the y or the x-intercept, it's a lot of these irrational numbers. So in your book, it has negative 1.943. So if you have an irrational number, you're just going to set it equal to that irrational number. So here, that graph, the 3x cubed plus 5x squared plus 3, it intercepts at x equals negative 1.934. And then also you have this graph right here. You're going to set it equal to 0, and you're going to get 7. So your two answers are 7 and negative 1.934. So if it's complicated, you don't have to do any extra steps. You're just going to write it down right there. Example 4. So we have a graph that looks like that. We have to go ahead and simplify it. We can't really simplify because there's one on each side. I'm going to move this term over so I can have it set equal to 0. And that's what you always want for all of these. You're always setting them equal to 0 because in the end, you're setting each of the roots equal to 0. So we have 0 is equal to negative 5x to the 4th power plus 5x cubed minus 8x squared minus 2x. Factor out common factor. They don't have a number in common, but they have at least an x in common. Plus 5x squared minus 8x minus 2. From then, you go ahead, it's a cube, you go ahead and graph it and try to find that number. If it's a whole number, you divide and you do synthetic division. If it's a irrational number, so you have a lot of decimal places, and I'll show you for this example how it's going to look like in any one of these stops. But you go ahead and you graph it, and when you graph it, you're going to end up with x being equal to negative 0.2149. You can round it to the hundreds. Actually, I would recommend the thousands or 10,000s. I will say thousands. And then you set each of these equal to 0. So x equals 0, just be 0. This, I'll end up with this fraction, right, or this number right there. Last one, it's a word problem. So this word problem, all you do is you're basically solving for it. They give you what the height is, they give you what v is. So you go ahead and plug it in. So we have negative 4.9 t squared. We don't have what t squared is, so I'm going to put t squared plus the v, I'm guessing it's velocity, so 5t plus the height, which is 25. Okay, now we have that, and we go ahead and see if we can simplify. It's a squared, so we can factor it by trial and error. We can't. We can use quadratic formula for this. So this is a, this is b, this is c. Quadratic formula is negative b, negative 5, plus or minus the square root of b squared, 5 squared, minus 4 times a, which is negative 4.9, times c, which is 25, divided by 2 times a, which is negative 4.9. So now going step by step, go ahead and simplify underneath the radical. 5 squared minus 4 times negative 4. If you multiply all of that together, you end up with 515. So make sure you have, you're doing it step by step, so 25, it'll be plus whatever the product of this is. So 515 over negative 9.8. After that, remember this means negative 5 plus radical 515 divided by negative 9.8. And it also means negative 5 minus the square root of 515 over negative 0.98. Solve for them separately. That means there's two answers. For the first one, when you add, you end up with negative 1.81. For this, when you add them together, you get 2.83. And for time, it says after the number of time, that's what the T is for. You can't have negative seconds, and that's why they go for the 2.83 seconds. That's how long it takes. You can read the word problem, what they're asking you for on your book, but just take this step by step, and then you'll do great. Bye.